Welcome back. Let's do question 1.3. For which value of n will the sum of the first n terms of the arithmetic sequence in question 1.2 be equal to the nth term of the quadratic sequence in question 1.1? Right, from question 1.1, we managed to find that Tn is equal to 3n squared minus 8n plus 7. This is the quadratic sequence in question 1.1. So it says, for which value of n will the sum of the first n terms of the arithmetic sequence in question 1.2 be equal to the nth term of the quadratic sequence in question 1.1. So this is the nth term for the quadratic sequence. Let's deal with the sum of the first n terms of the arithmetic sequence. This is our arithmetic sequence. We know that the formula is Sn is equal to n over 2 into a plus n minus 1d. Okay, right. Or you can say that, okay, so our a is 35 and our common difference is negative 27. 28 minus 35, that is negatives. And our common difference is negative 7. 28 minus 35 is negative 7. 21 minus 28 is negative 7. So it means Sn is equal to n over 2 in 2 times 35, which is our first term, plus n minus 1. Then our difference is negative 7. So now we can simplify this equation. Let's just do that. So we have Sn is equal to n over 2 and then 70. Then we're distributing negative 7 here. We have to be careful. Negative 7n plus 7. And then 70 plus 7, that is 77. So Sn is equal to n over 2. Then negative 7n plus 7, 77. Now we can distribute our n over 2. We can distribute our n over 2. Right. Maybe if you want, you can distribute n first and then after that distribute half. 1 over 2 after. But if you say n over 2 times negative 7n, what do we get? We get negative 7n squared over 2, isn't it? Alright, so Sn is equal to negative 7n squared over 2. And then n over 2 times 7, n over 2 times 77 is equal to 77 n over 2. So it's going to be plus 77 n over 2. So this is our Sn. Now, for which values of n will the sum of the first n terms of the arithmetic sequence, which is this one, in question 1.2 be equal to the nth term of the quadratic sequence in question 1.1, which is this one. So now we're saying negative 7n squared over 2 plus 77n over 2 is equal to 3n squared minus 8n plus 7. And then to get rid of this denominator, we multiply by the LCD. In this case, it is 2. To get rid of the 2, let's multiply by 8. So we're multiplying every term by 2. So it's going to be negative 7n squared plus 77n is equal to 6n squared minus 16n plus 14. Let's simplify this. Right, let's bring 6n squared to the left hand side. It becomes negative 7n squared minus 6n squared, which is negative 13n squared. And then 77n plus 16 is 93. So it's positive 93. So it's positive 93. And then we bring 14 to the left hand side, becomes negative 14 is equal to 0. And then let's just divide everything by negative 1. So it's 13n squared minus 93n plus 14 is equal to 0. Right, so, or you could have moved these ones to the right. It was also going to give you this one straight away, this standard form. So now from here we can use our quadratic formula. So remember, n is equal to negative b plus or minus the square root of b squared minus 4ac, all this over 2a, and then we substitute n is equal to, our b is negative 93, so it's minus negative 93 plus or minus the square root of negative 93 squared minus 4. Our a is 13, and then our c is 14. This over 2 times 13. And when you use a calculator, you're going to get that n is equal to 7, or n is equal to 2 over 13. Okay, which is not applicable because n should be a positive integer. N is the number of terms, so it cannot be negative, cannot be a decimal. Or we can factorize here. If you can factorize, your factors would be n minus 7 and then 3n minus 2 is equal to 0. Then that get that n is equal to 7, or n is equal to 2 over 13. Then this is not applicable. For which value of n will the sum of the first n terms of an arithmetic sequence in question 1, 2 be equal to the nth term of the quadratic sequence in question 1, 1, when n is equal to 7? That's the answer.